The new Fortigate 3700F secures data centers that are part of hybrid IT networks and critical to an organization's digital acceleration journey. As the industry's only compact network firewall appliance with multiple 400 gigabit Ethernet interfaces, the Fortigate 3700F supports high-speed connections between the data center and multi-clouds to deliver an optimal digital experience for customers no matter where their applications are hosted. There are several network applications where low latency connections are critical in order to move high volumes of small packets through the system. For instance, online gaming and online meeting applications need to do so seamlessly in order to maximize the user experience. Another important application is low-latency, high-frequency trading, the practice of leveraging microsecond advantages in network speed and latency to get information between traders as quickly as possible. With 4 ultra-low latency ports supporting up to 25 gigabits per second, the Fortigate 3700F is an ideal choice for high-frequency trading companies and other financial institutions who need to segment their networks. Today's demonstration will show 2 tests putting the Fortigate 3700F through its paces. The first tests will show its ultra-low latency and throughput performance using the latest 400 gigabit Ethernet tester from Spirent, the SPT-N4U. The Fortigate's Ethernet ports will be processing up to 400 gigabits of traffic, while at the same time the ultra-low latency ports will also be bombarded with traffic, to show the consistent low latency the 3700F can achieve even under heavy loads. Here we're starting up the traffic for both the ultra-low latency and 400 gigabit ports. The top bandwidth widget shows the layer 2 bandwidth of the ultra-low latency ports, and the second row shows the bandwidth on the 400 gigabit QSFP-DD ports. We have a total of 33 gigabits, 16 3/4 gigabits bidirectional for the ultra-low latency ports, and 239 gigabits, also bidirectional, on the 400 gigabit QSFP-DD ports. The traffic passing through the ultra-low latency ports has an average latency of 1 to 1.18 microseconds. This is despite the heavy load from the 400 gigabit QSFP-DD ports. The RFC2544 test with 64-byte packets is used to test the ultra-low latency to show the lowest latency possible that can be achieved by the Fortigate 3700F. We can see here that the latency remains consistent and is not impacted by any additional traffic load being handled at the same time on other ports. The 400 gigabit QSFP-DD ports have a latency of around 4.92 to 5.36 microseconds. The test on these ports has a larger packet size, 1518 bytes, to create a higher bandwidth and introduce more load to the system. This simulates a typical scenario where there could be a heavy load of regular traffic while still needing to keep the ultra-low latency performance stable. Now the test ramps down. For the next test, we'll show the ultra-low latency ports and 400 gigabit ports tested separately at the most optimum latency with 64-byte packets as the test traffic pattern. First, we run traffic only on the ultra-low latency ports. We can see that the lowest latency is 1.16 microseconds. Another important factor to note is that the average jitter in this test is also extremely low at 0.01 microseconds. Also note that for this test with 4 25 gigabit Ethernet SFP ports, we are hitting almost the maximum bandwidth at 98.3 gigabits, about 153 million packets per second. Now to test the 400 gigabit QSFP-DD ports. We again run 64-byte packets to demonstrate the best latency numbers on these ports. 64-byte packets are typically used in standard tests to demonstrate the lowest latency the port can achieve. As you can see, the latency is approximately 3.6 microseconds, with an average jitter of 0.06 microseconds. Now we'll show a test for cases where customers can leverage the Fortigate 3700F for edge security as a data center firewall or as an internal segmentation firewall. For this test, we worked with the Spirent CyberFlood C200 platform, connecting 2 of them to the Fortigate. The network traffic pattern we are testing with is Spirent's own enterprise mix, with a combination of applications that are typically seen in enterprise traffic, such as HTTP, FTP, SMB, Exchange, SIP, and RTSP. The policy we used on the Fortigate is our standard threat protection configuration, IPS policy with high security, application control, and antivirus enabled, as well as certificate inspection. Logging is enabled as well for additional visibility into the traffic. Let's start the test. On the right side, we have the bandwidth of the enterprise mix with threat protection enabled on the Fortigate 3700F. The traffic starts to ramp up, and we can see the different traffic protocol percentages with HTTP, FTP, and IMAP4 ramping up quickly. The traffic load is gradually approaching 75 gigabits per second of the enterprise traffic mix. The CPU is averaging 84% with all IPS engines working at 95 to 97%, indicating that all of the traffic is hitting the IPS engines for inspection. Finally, the load reaches a total of 75 gigabits per second of inspected traffic with threat protection configured. The full test runs for 5 minutes and 50 seconds with all transactions passing, a 100% success rate. The bandwidth from each of the two Spirent cyberflood devices was 37.5 gigabits per second, aggregating to 75 gigabits per second of the enterprise traffic mix. And we can see from Spirent's report that all transactions succeeded with 0 failures. To summarize the traffic load test, we configured the Fortigate 3700F for application control, antivirus, and IPS with logging enabled and subjected it to Spirent's enterprise mix, resulting in successfully processing 75 gigabits per second of traffic.